Hi, it's time for another math easy solution. Tear and discuss further into the applied project How Fast Does a Tank Drain video series, and I'll go over question 4 and look at part A. In my earlier videos I went over questions 1, 2, and 3 as well as an introduction to question 4, and now I'll solve part A. And again, if you haven't seen those videos, make sure to watch those, as I'm not gonna go over a recap of this applied project, but instead I'm gonna jump straight into part A of question 4. So let's just scroll all the way down. Okay, so part A asks, suppose the tank has a shape of a sphere with radius 2 meters and is initially half full of water. If the radius of the circular hole is 1 centimeter and we take acceleration due to gravity g equals to 10 meters per second squared, show that h, the height, satisfies this differential equation: 4h minus h squared times dh over dt equals to negative 0.0001 square root 20 times h. Part B I'll do in the next video. It says how long will it take for the water to drain completely. So anyways, let's look at part A and let's draw what we know. This is basically draw what it's asking. So suppose the tank has the shape of a sphere. So it's a sphere. Let's draw this out. It's a big giant sphere like that. So it is a sphere and it's initially half full of water and has radius 2 meters. So let's just draw this. From here to here is 2 meters. So the full radius is, alright, r of the tank. Our tank equals 2 meters. So radius of the tank equals to 2 meters. And it's initially half filled with water, but so anyways, you have water inside. I won't draw it exactly at half full, but I'll just draw let's just draw a general shape, right, like this. I'm just gonna draw the water level. What I'm drawing is the water level 3D of it. So let's just say it's at a water level such that it's over here. So, and if this is the height of it, I'll draw this a bit lower there. So this is, let's say this is the height axis right there. So at this point we have a height h of this water level, and then the radius of this, I'm just going to draw this is r. As you can see here, this is a bit higher than the halfway point. This is just a general r and h that I'm drawing, general water level height and radius, and here it's less than 2 meters. So basically as you go up in h, this decreases as you go down away from the middle. It also changes as well. So r is a function of h. This is the radius of the water level. The full radius of the tank is 2 meters. And we're given that it's initially half full. So then this means is that initially, I'll just write initially and we'll set it as time equals to 0, t equals to 0 is equal to 2 meters. Because remember, this is half full and the radius is 2 meters. It's a sphere. So it's half full. It's up to the halfway point, which is again the radius. Distance to the half is the radius, so it's 2 meters is the water height. So that's our initially half full condition. And if the radius of the circular hole is 1 centimeter, that is the circular outlet hole. Again, from earlier videos, that's what I would draw. At the bottom you would have an outlet. So here has a radius. We'll call this r of the hole, rh, which equals to 1 centimeter. And here we're also given that, again, g is 10 meters per second squared. So we want to show that it's equal to this over here. And again, from my earlier video on introduction to this question 4, I derived this formula right here: a of h dh over dt equals negative a square root 2gh. So let's write that down. So recall from earlier video and from above, we have a of h, so this differential equation, dh over dt is equal to negative a square root 2gh. So I'll double check that's what it is. Yeah, so let's just scroll. Yeah, so a over h dh over dt equals to negative a square root 2gh. So that's what we have here, where this a of h is the cross-sectional area of the water right here at the water height. So that's this area right here. So this is our, let's write it inside, that's our A of H. So that's a cross-sectional area at whatever the water height or water level is at any point. Yeah, so this is our formula where, I'll write this down, so where A of H is equal to, well, it's the area of this cross-sectional section, and again, the area of that is just pi r squared, where r is the radius of that section. This is pi r squared. And again, recall r is equal to a function of h. As you go up and down with h, you're going to see radius drop. As you go really, really low, radius is going to be very, very small, like something like that. Yeah, so anyways, let's go back to here. So this is what we have. A of h is pi r squared, and our g is gravity. That's just acceleration due to gravity. That's 10 meters per second squared. And the last part, a, that is the area of the outlet. That is actually this area. So that is our A. So that's and then the radius is 1 centimeter. So what we have is we have the radius of r h squared right here, but it's in centimeters. We need to change that into meters. So area of that little hole is pi r h squared. And then where r h is equal to, let's just convert the units because we're dealing with meters everywhere and seconds, and as well as the radius of the tank is in 2 meters. So change this into meters. Yeah, scroll here. So that's 2 meters. Everything's 2 meters. So this is 1 centimeter times this by 1 meter over 100 centimeters. That's the conversion. And then this is just equal to 1 over 100 meters, which equals to, well, 0.01 meters. So that's what RH is equal to. So now let's plug in what we have now. So this AH is pi r squared. So we get pi r squared dH over dt is equal to negative, and A is pi r h squared. So this is pi, and then I'm going to write this as 1 over 100 just to keep it as a fraction like that. And then this is squared, square root 2 times g. So g is 10, and then times h, like that. Yeah, and what we have here, this pi's cancel, and then right now I'm just going to multiply this 1 over 100 squared on its own. I'll put a bubble like that. 1 over 100 squared, the same thing as writing 1 over 100 squared, which equals to, well, 100 times 100 at the bottom, and then again, that's just, well, 100 times 100, you just add 2 zeros to it, that's just 10,000. This equals to 1 over 10,000. And then divide this out. This is equal to, and again, just to keep in mind, when you have 1 over divided by a factor of 10 like this at the bottom, and then you just move 1 decimal place for every 0. So if it's 1 divided by 10, that's 0.1. If it's 1 divided by 100, that's 0.01. So we just go, so this is 2 decimal places, 2 zeros, so we need to go 4 decimal places. Go 0.00, so it's 1, 2, 3, and then 4. So that's what 1 over 100 squared is equal to. So what we end up getting is r squared dH over dt is equal to, and then this is the pi's cancel, 1 over 100 squared is just this number here. So negative 0.0001 square root 2 times 10 is 20 times g, so 20g. So this is actually exactly what we're trying to solve, except for the r squared. So that's this exact figure here. So we just need to get what r squared is. So again, as I stated above, note that r is a function of h. And you could see this by, well, let's just plot this out. So if we were to plot, say, the height and radius axis, so we have, this is the height h, and then I'll draw this at the bottom here. This is the radius r of the tank, or of the this is the radius of the water height. So what we end up having is, let's say here's our sphere. So we draw the sphere like that. Yeah, just pretend it's perfectly circular. So anyways, we have something like that, and then at, let's say, at any random height here, at random, we have a radius r, and this is the height h, like that. And now we've graphed where the r-axis hits the bottom here, so this means that the origin, so again, because we have h, the height 0 at this point here, and also the radius is 0 at here, so the origin of this circle, origin has a coordinates of, well, 0 for radius and 2 meters for height, because it's halfway, halfway over here, so because we know that the radius of the tank is 2 meters. Again, where the radius here is 2 meters, so radius equals to our tank equals to 2 meters. Yeah, so that's just the equation of a circle with an origin 0, 2. So what we have now is recall from my earlier video on equation of a circle. So equation of a circle, and that equation is, well, it's just going to be, again, make sure to watch out in my earlier video. I'll put that in the video link below as well to get more info on the equation of a circle. So what we have is r, since the it's at the origin is at 0 and 2, or r equals to 0, so we have r squared plus, and then here the origin is shifted, so h minus 2. So you can put a minus whatever the origin is for that coordinate. So this is h, so h minus 2, it's a squared. Yeah, so you put a minus again. If you were to think about putting in h equals to 2, then this cancels, it goes to 0. Same thing if you put r as 0, that cancels. That's why we have this negative 2 when the origin is positive 2. And then we have to equal to the radius of the circle squared, where the radius is, well, our tank, that's just 2 meters. So 2 squared, which equals to 4. So if we rearrange this, we get r squared, let's move this on the other side, equals to 4 minus h minus 2 squared. So now let's just solve for h minus 2, just to expand this out. This FOIL method, this is equal to, well, h over h minus 2 times h minus 2. Again, recall the FOIL method. If you want to learn more about it, watch my earlier video in the video link below. So you multiply this by this, which equals to, well, h squared added to h times negative 2, so it's negative 2h. Then multiply then we add it from this one, negative 2 times h. And then the last one, negative 2 times negative 2, which is plus 4. This equals to, well, h squared minus, and here this is, these add up for h, and then we have plus 4, like that. And I'll just circle this, just a side calculation. Now we can throw this inside, so this equals to 4 minus, and then this is, because it's a minus, we just put a negative sign in front of each one. So minus h squared plus 4h, and then minus 4. As you can see, the 4's cancel. And then we'll just move this 4h in front of this negative h squared, so we get r squared equals to 4h minus h squared. So that is what our r squared is. Let's just scroll up, and then let's just throw everything in this r squared, and we get the differential equation which we were supposed to find, which we were asked to find. So we have 4h, I'll write 4h minus h squared, dh over dt is equal to negative 0.0001 square root 20 and then h. And there is the differential equation, which I will evaluate in the next part B video of this question. So that's what it is, and then let's just look exactly at the question, see if they're identical. Yeah, so we have 4h minus h squared dh over dt, negative 0.0001 square root 20h, which is identical to this. So our check mark, we got it correct. Anyways, that's all for today. Hopefully you'll learn from this pretty useful question video on determining differential equation for the water height for a sphere, so it's non-cylindrical shape as opposed to questions 1, 2, and 3. In the next video I'll go over how long it will take for the water to drain completely. Anyways, that's all for today. Hopefully you'll learn from this pretty interesting video, and like always, make sure to watch my earlier videos, questions 1, 2, 3, and 4 introduction, And like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.